Leo is a theoretical physicist and the director emeritus of the Centro Internacional de Física de Bogota, which was inspired by ICTP in Trieste. He's the recipient of the 2024 Joseph A. Burton Forum Award of the Advanced American Physical Society for establishing programs in physics education and research in Latin America and the Caribbean that increase regional capacity for promoting international scientific cooperation across continents and regions of the world, and the creation of the Centro Internacional de Física de Colombia. Leo graduated from La Sapienza University in Rome, and with this, I will let Leo start his talk. Thank you.
Thank you, Antoine. Thank you for this. Thank you for this invitation. I'm pleased to have this opportunity of talking about these problems, which are rather general and rather not specifically linked to my activity. Well, science is a public good. This is a statement with which today is not so difficult to agree. However, it has acquired content only very recently, less than 100 years ago. The status of public good reflects its being object of the general policy of a country, and reflects in being also an aspect of international relations. This does not mean that earlier science had no contact with the power. Scientific and technological breakthrough have been used mostly in war. Famous is the case of Archimedes, who were burning the Roman ships during the Syracuse siege, taking advantage of a geometrical property of the parabola. Assyrians knew how to attack a fortified city. Catapults have been used for the same purpose. A change was with the appearance of gunpowder. Gunpowder appeared in Europe about seven centuries ago, and it changed the way wars were fought. There were technological developments, there was an exchange of experts. Some countries had a broader appropriation of this technique, of these capacities, others less. It has been argued that the fall of one of the causes of the Turkish Empire decline has been its inadequacy of technical updating in this aspect. And when in the 19th centuries in France, chassepots were invented, this weapon played a major role in many wars, including the Secession War. And as an Italian, I can recall the relevance they had for the fall in 1849 of the Roman Republic. Last century, nitroglycerin and gases were used broadly. However, behind this long list, one would find no recognition by the states of the importance of science as a sector to be included in the budget, in the policy, and to be promoted. Individuals were traveling to centers where science was developing, were making discoveries. Occasionally, this may have had also applications of public interest. Well known is a sentence attributed to Faraday that electricity would contribute to the finances of the British Empire. In the case of nitroglycerin, the military usefulness of the discovery was realized a posteriori, after the discovery by Sobrero and Pelouse, or its industrialization by Nobel. Of course, one could say there have been cases of scientists who had important positions in many courts: Leonardo, Voltaire, Tycho Brahe, Euler are the first names that would come to our mind. But they were court scientists, jewels of the crown, I want to say. But just as the courts had official musicians, there was a change that would revolution the vision of science, no longer as an individual enterprise or an important side activity of a university, and this was triggered by the Second World War. There are at least 3 cases in the Second World War which are especially representative of the revolution of the interface between science and political power. In Germany, there were 2 lines of research: the line of research on nuclear fission and that on the V2 that kept alive, despite the defeat on battle camps, the last hopes the Nazi Reich, the Third Reich, had to revert a lost military situation. In Britain, Turing has been able to break the Nazi coding system and played a major role for the war. And in the US, the Manhattan Project was determined to end the war with the bombs of Hiroshima and Nagasaki. However, if we look at these 3 cases, they cannot be used and were not as an evidence or a proof that there was a science policy on part of these 3 countries. No, they simply indicate that in a certain historical moment, the political and military centers of power realized, or perhaps hoped, that science could be helpful for what they were doing independent of science. The real birth of the concept of science policy is to be traced to the days immediately before the end of the Second World War. A new vision, which to some extent is the current one, emerged in the United States. Its 0 year dates back to 1945. Oh, I forgot to. Okay, I forgot to move the. I'm sorry. I beg your pardon. When in July, on July 25th, Vannevar Bush responded to a letter which had been sent to him 8 months earlier by President Roosevelt, stating that although science does not represent a solution to individual, social, and economic problems, without scientific progress, there are no achievements that can guarantee our health, prosperity, and security. Promotion and development of science were thus recognized as full-fledged functions of the state, part of and functional to the mandate the state receives from the population. Science, the Endless Frontier, is a historical document, not only for this. It is also a document of an admirable modernity. A statement of this document stands out. The development of new frontiers must be accessible to all its citizens. Gender is not mentioned, but the principle is established that advances a paradigm shift that today means that the study of science and the practice of science is no longer reserved to those who possess the Y chromosome. Of course, all citizens are much more than gender. A few days ago, I was participating in the annual Congress of the American Physical Society. Besides the scientific talks, I appreciated that a subject often mentioned has been that of inclusion. Inclusion that must be socially equitable. This is a general political problem, of course, but inclusion is not only a recognition of individual rights. It means that the state make use of its potential for all its citizens. The implementation of such a goal is not a trivial issue. There may be forward and backward steps, and my strong linkage with the Latin American science community makes me look with worry to a recent controversial decision of the United States Supreme Court that indirectly affects the collective right of that community and also the other minorities to access higher education. And the access of higher education is basic for the real accessibility to another right, specific for this talk, that of accessing and using science, right recognized by the United Nations as part of the human rights. Concerning the former, it should be obvious that access to higher education cannot be a satisfactory goal. If it is followed by a high dropout case and dropout rate, something which is very frequent in Latin America and not only there. Concerning the second right, it is increasingly understood that equity reasons and the interest itself of the countries impose that it implies as well the right to be scientists, not only to access and use science, to make research, a comment that will pave the way, the link to my discussion about science policy and science diplomacy. In any case, Bush wrote straight that guaranteeing such accessibility is or should be incumbent upon the state, since without scientific progress, we could not improve our standard of living or increase the number of jobs for our citizens, and we could not have maintained our freedoms against tyranny. Also, he recognized that publicly and privately supported colleges, universities, and research institutes are the centers of basic research. The actual implementation of these rights requires policy, and policies are framed on ethical and philosophical principles, but are also conditioned by many external considerations. Thus, science policy is unavoidably an aspect of political science, also it has some peculiar characteristics. The answer it gives to a specific issue necessarily reflects general political thought, and difference may be found among these answers. It is clear that the science policy envisioned by a liberal or a conservative thinker are different, depends on, nevertheless, on constraints which are imposed or assumed to be imposed by consideration of opportunity cost. Unfortunately, science benefits are mostly intangible, and the tangible effects may be harvested years or decades later. And political science will tell that a policymaker will often have as its compass or her compass the strengthening of his or her consensus, post in review of the next election. But despite this limitation, certain facts are objective. Their importance may differ greatly because of cultural and historical difference. And my experience comes mainly from many years in Latin America. However, the reflections I'm going to share, based on that experience, might provide some clue for other situations. In Bush vision, one point is clear. The fundamental rights are two, and they are entangled: access to education and access to science. However, it would be naive to believe that the great progress of American science is the direct result of the great idea of Bush. As a matter of fact, once again, the progress of science and its incorporation in the state mandate was the result of political and meta-scientific consideration. In 1957, Soviet Union launched its first Sputnik. 1 month later, Laika was the first living being in the space. 3 years after, Yuri Gagarin was the first man on the space. And the competition for the space produced a scientific acceleration, which has indeed its seeds in Science Without Endless Frontier, but was a political decision, not an application of science policy. Actually, this reflected on scientific education. It is of those same years the experience of several new approaches to the teaching of physics, both at college level. It is emblematic, the case of the PSSC project, and at university level. And there's no need to mention this here in Berkeley, because the Berkeley project was really the leading experience of this sort. This initiative had also an impact in Latin America. However, one should not forget one of the most striking differences between US and Latin American higher education system for what concerns scientific disciplines. I'm not going to discuss this in detail, but just let me notice that whereas Harvard was established about 100 years after St. Thomas University in Santo Domingo, the first course of chemistry at Yale dates back to the first years of the 19th century, whereas in Latin American university, at that moment, they were still paying their price to the structure given by the Spanish crown, not to speak of their absence in Brazil. Science would have to wait all over the century and to draw only in the second half, or mainly in the second half of the 19th century in Latin America. However, in Latin America at that moment, the second half of the 20th century, there were some advanced initiatives in certain countries. The three fathers of physics, Giambiagi from Argentina, Leite Lopez from Brazil, and Moschinsky from Mexico, created the ELAF, the Latin American School of Physics. In other regions, Robert Little from Austin University, from University of Austin, created the CURCAF, the Central American course of physics, which was a similar series of courses, however, were mainly focused on teaching because of the different level of development of science in Central America. If one looks back after 50 years to this experience, can we say that they have been successful? Well, only up to a certain level. Science policy was correct, but its weight in general policy is still limited. And this is not only a problem of funding. It is true that the average investment in science in Latin America is only 0.6% of its gross national product, but also in education it is about 4%, and 4% is comparable to that of advanced countries. The problem is that these countries have structural problems, and these structural problems are not faced. The dropout, I was mentioning, the socioeconomic differences, the difference in a given country between capital, town, and periphery. And so, in many developing countries, what is necessary is to make brave decisions, entangling education and science policy, attacking the structural problems, to be conscious that the time is not a neutral variable. It may be very hard to believe, but the needs now are similar to those of 45 years ago, when I started being interested in these problems. It looks like, if one takes the out-of-time Macondo atmosphere of Garcia Marquez's 100 Years of Solitude, and finds that it pervades science policy. I have two striking personal examples. In 1995, APS honored me with the John Whitley Award. This year, I had another award. The one was mentioned by Dr. Islegen-Wojdyla when he introduced me. When I prepared my talk for this award, I found that what I had said in 1995 was still tremendously actual. Moreover, a few months ago, I could write an article for a Dominican Republic online newspaper. This article was plainly a plagiarism of what I had been said 35 years ago by two Colombian colleagues, Marta Lucia Guardiola and José Luis Villaveses, and myself, at a Third World Academy of Science conference. There's another structural problems faced by many of most Latin American countries. These countries have an economic metrics which is based on very volatile items. tourism, services, remittances. And high-tech is important, but not produced nationally. Even less it is object of the advanced research. And this despite the popularity of a magic word which is very popular nowadays, innovation. This reflects and is rooted on their scientific and education system. Science is Cinderella. It is mentioned in the electoral campaigns, but when arrives the day after the election, it is immediately forgotten, and the attention shifts to the everyday urgent problems. The average Latin American investment in science is now of the same order as it was decades ago. Difference between the countries are huge. Just an example, I was mentioning 0.6% for the average, but in a couple of Latin American countries, it is one order of magnitude less, is 0.4 per thousand or 0.3 per thousand. There's a mantra role which circulates, is the mantra role of a mythical 2%. But this is a mantra role which is transmitted from one generation of policymaker to another, but just for a few days, and then it's forgotten. And again, I want to stress that the difference within a country. This may be social, geographical, sometimes they're ethnic, and they are between the capital and small towns, between the small towns and villages. All of these conditions make the fundamental human right to science, which is approved unanimously by UNESCO in 2017, just a few years ago, to remain one of those wishful decisions of United Nations, which are applauded in the summit of head of state speeches, but then will never reflect in actions. And science policy is often poisoned. It is conditioned by the structural problems it once could, but is unable to solve, which should link it to educational policy, but usually the plans for the two are independent of each other. It is preferable to cultivate the illusion of innovation and technological development. There was something which was said by the Argentinian Nobel Prize Hussein in '54. He was warning against the pitfall of research oriented to immediate application, supposedly useful to society, and this idea, however, is not part of the policy. The point is that short-time actions are politically more rewarding than creating infrastructure, be in such infrastructure a center of science or an important facility. And the problem is very simple. Politicians are simply terrified by the idea that who would harvest what they've seeded would be a barbarian of opposite political leader or political party. And so they will benefit of his policy. And so policy looking too far away are not popular among the politicians. This consideration can be summarized, saying, yes, science policy is part of policy at large, but the conditions on it make it a very peculiar sector of science policy. Instead, if we move to the problem of science diplomacy and diplomacy, the relation is quite different. Diplomacy exists since ever. Science diplomacy, instead, is a fluid term, to some extent an oxymoron, because diplomats represent their governments and are bound to abide its policy, even if within the limits of an established diplomatic code. There is a popular diplomatic joke that when a diplomat says yes, what he really means is maybe. When he say maybe, what he really means is no. And if instead he say no, this simply means that he is not a diplomat. Science diplomacy, on the contrary, is largely based on consensus, on promoting formal forms of international collaboration. And the final goal is to face a general problem with solutions which are of general interest and usefulness. However, these goals often require a political international decision. And for this reason, from the point of view of the governments, science diplomacy is an aspect of diplomacy, just like cultural diplomacy or sport diplomacy. On the other hand, there's the fact that the main actors are scientists, they are not diplomats. They may even be not aligned with the policy of their country, and they act as a freelance, and this has a lot of implications on the actual development of science policy. The picture is even more complex because the target may be the involvement of international organizations. The international organizations are actors themselves. They are bound by the limits imposed by the fact that their stakeholders are member states, but they have also an independent history, an independent goal. The first case of science diplomacy with such a broad and vague definition were due to accidental forms of scientific migration. They were consequences of local political decisions or situations. In Latin America, the birth of physics is linked to the name of Mossotti. Mossotti was an Italian scientist who was accepted the invitation of Argentinian President Bernardino Rivadavia and established the first physics laboratory in the southern continent. Well, the reason why he did this was that he was incompatible with the regime of his town, which was part of the Papal State. In Germany, Bismarck launched the Kulturkampf in the end of the 19th century. And the Kulturkampf led to the forced migration of all the Jesuits. Some of them went to Ecuador. The result was the creation of the Quito Observatory. One could argue whether these examples have to be considered as science diplomacy or just migration of scientists. And so it depends very much how generously broad is our definition of science diplomacy, if these are or are not. Personally, I consider that in the case of Ecuadorian case, it is rather a case of science diplomacy because the migration of Jesuits from Germany was a collective fact which to some extent reflected in a kind of science diplomacy of certain vision which included science, that of the Jesuits in the specific case. But there are cases, however, in which it is clear that scientists have been used as cultural ambassadors of their countries. And in this case, are not of ambiguous interpretation as those the mention of those I just mentioned. They happened during in Italy during the fascism. The fascist Italy in the 30s decided to strengthen its relation with the Italian origin communities in Latin America. In 1934, Enrico Fermi visited Argentina, Uruguay, and Brazil. 3 years later, Tullio Levi-Civita visited Peru and Brazil. And in the case of Levi-Civita, there are 2 things I would like to mention. Levicivita in Peru expressed clearly his vision that he felt himself as an ambassador opening the path for future connections between Italy and Latin America. But however, one must remind that the extension of his visit to Brazil was political. It was discussed personally by a Brazilian scientist, Teodoro Ramos, and Mussolini, a few months earlier of the visit. And Mussolini, well, this is the sad side of the story. A few months after Levicivita visited Brazil, this was September or October 37, in February 38, started launching his anti-Semitic campaign, which would have Levicivita as a victim and would be rationalized with the racist Manifesto della Razza of July 38 and by the laws of September 38, which expelled the Jewish professor from the university. Well, they not only expelled the Jewish professor from the university, who were much broader, but for concerned university, they meant the expulsion of about 9% of Italian professors from the university. Now, it is beyond the scope, beyond my scope of my talk to discuss the impact this had on Latin American science. But I've written about that. And if anybody's interested, I could provide some interesting details on the influence this fact had on development of science in science in broad sense, also social sciences. For example, just to give an example, Tullio Ascarelli was a lawyer, introduced the commercial right to Latin America as a result. Anyway, but despite this example, again, the roots of what we consider now science diplomacy are more recent. And again, they are linked to the experience of the Second World War. Because it is true that in 1931 had been created the International Council of Scientific Union, and it was a scientist initiative. But the two important initiatives I would like to mention, because their goal was based on general principle, are UNESCO and Purvash. Yes, I'm sorry. I returned back because there was a problem of a microphone. UNESCO is famous for its famous preamble in which it is stated that the barriers of peace must be built in the minds. And the Purvash movement was very important for the weapon control and was honored in 1995 with the Nobel Prize for Peace. The two most important features of science diplomacy are advocating for, as I was saying before, for general principle and the promotion of international cooperation. Therefore, it cannot be surprising that physics, because of the importance of international cooperations having physics, has played a major role for the development of science diplomacy. For it, there is a major milestone. It was the 9th Rochester Conference, which took place in Kiev in 1959. This was following a 1956 mission of a number of a dozen of US physicists to Soviet Union, high-energy physicists. Well, the Rochester Conference are high-energy conference, and Kiev was the first conference taking place in Soviet Union, but was instrumental to start many international cooperation, which, for example, eventually ended in participation of Russian scientists in CERN. the participation of Western scientists in research at Dubna. Well, however, as I mentioned in the title, my aim is not that much to discuss the role science diplomacy may have in advanced countries. Role, as anyway, not always successful, because there have been, well, there are certain difficulties which are well known. If we think to the difficulties of the attempt in fighting the climate change, if we think about the difficulty we found to promote, people found to promote a decent vaccine availability during the recent pandemic, it is clear that despite these are object of science diplomacy, other consideration of the current diplomacy prevailed. In the case of vaccines, science diplomacy had the goal of liberalization, at least temporarily, of the patents, but the diplomacy prevailed. When this matter was brought to the attention of the World Trade Organization, the majority of the member states supported the initiative of India and South Africa, but the diplomatic weight was not enough to reach the consensus that that organization needs in order to make a decision effective. Science diplomacy has different characteristics, moreover, in advanced and developing countries. What matters for developing countries is often much more basic than in advanced countries. Personally, I am a convinced supporter of the idea that equitable scientific development requires that scientific infrastructure in developing countries be strengthened in order to make possible for their scientists not to leave the country and participate also in big international collaboration. Concretely, this means establishment of international center of science, the creation of advanced research facilities. And for this, successful example exists. 60 years ago, Abdus Salam founded the International Center of Theoretical Physics in Trieste. Today, that center bears his name. It is a beautiful example of applied science diplomacy. However, if one looks in detail to the history of ICTP, the negative position of the British delegate in the Atomic Energy General Assembly, where it was approved, cannot be forgotten. In his view, scientific development of the Third World was not a credible priority. It was essential the support from Italy, but also the motivation of Italy must be nuanced. It was a result of the long-term vision of Paolo Budinic, but it is also true that by creating ICTP, Italy was putting on the table a unique opportunity of economic relevance for the economy of Trieste, and Trieste was just returned to Italy after about a decade of administration by Allied forces, American and British. ICTP example has been followed by many cases and many proposals. All of them fall in a category, which is the category, a typical category of science diplomacy, that of the science centers of UNESCO. But the short time lived, for example, Multisciencias in Peru, ITAP in the US, and the failures of other proposals in Spain, Colombia, Ecuador, Dominican Republic show that science diplomacy must be conjugated with policy and diplomacy. Once more, the reasons of advanced countries to participate actively in this endeavor are not necessarily the same ideal motivation that as a science diplomat. European Union European Union has increasingly opened the possibility of participating in its 7-year programs for non-member states. But its priorities are the priorities which determine which projects must be financed, and they are defined by the Union, not by the developing countries. Does this nevertheless represent an opportunity for a developing country? Well, first of all, let me start with a frustrating experience. I had this experience many years ago in an important financing the energy of a very important country, irrelevant to name which country and which agency. But at that moment, I had recently founded with Eduardo Posada a center modeled on ICT, like ICTP. Actually, its activity was rather broad and included applied sectors of great relevance. It's the International Center of Physics, which is my affiliation now as a director emeritus of it. And among these sectors of great relevance were education, non-conventional energy, and also some far-looking idea, the development of energy physics, for example, in the Andean region. The reaction that the agency officer I met when I was inquiring about a possible support from that agency to our center was that an advanced science program in physics was not the priority of that agency, and so they were not concerned about intervention in the Andean region. I had a polemic question. I asked him whether his answer would have been the same if instead of me, who was an unknown person from Colombia, had been there Crick or Watson, the fathers of ADN. And well, I received an answer, the answer you could expect. Yes, would be the same. He did not consider the idea that one could make advanced science in a developing country. Now this has changed a little, but not much. So for a successful science diplomacy, developing countries must insist in any negotiation on their priorities for scientific development. And this closes the circle between science policy and science diplomacy. The developing country must have a science policy, which gives them the authority and credibility to do that. And in Latin America, this means also to have the braveness of really increasing the percentage of GNP invested in science. The average 0.6% must arrive at a decent level, and not today, not tomorrow, yesterday. This may allow to face the second big structural problem I was mentioning before, the establishment of big international facilities. Geographical reasons have made this possible for astronomy and astrophysics in Latin America. Sometimes again because it interests advanced countries. Currently, I want to mention the project that made me possible my presence here today, a second Latin American synchrotron in the Greater Caribbean. Support from advanced countries can be obtained. The project is strictly linked to a likewise project in Africa. In both regions, a geopolitical competition exists due to an increasing presence of Russia and China through the BRICS group, and also as a consequence of doubtful political choices made during the pandemic by Western countries. Science diplomacy is by definition international. The hope is to have from UNESCO the same support it gave to Sesame and in the Middle East synchrotron, which was supported also by United States, in which participate Turkey, Greece, Cyprus, Israel, Palestinian Authority, Republic of Iran. Of course, local funding will be necessary. In Central America, an 8-year sleeping proposal of a regional fund must still materialize its decision no, excuse me, is still materializing the decision by the head of state in the usual meetings. The local investors must understand that the future of their country requires high-tech development, whose return will compensate for the necessary investment. Is it a difficult and ambitious problem? Maybe. But the alternative for developing countries is simply to perpetuate the underdevelopment and to amplify the gap with the first world. In such a case, it will be vain to cultivate illusions about artificial intelligence, innovation, similar popular mantra. They will not rescue them from underdevelopment. Thank you.
Thank you very much. Do you have any questions online? Can you hear me? Yeah. So I have a question regarding developing countries, because after World War II, countries like South Korea and Japan and so were also kind of very much down under. And it seems that innovation kind of helped them to take the better end of it. So what is your take on this?
Well, you took the typical example, which is always brought which is always brought to mention, it is the case of Korea. But the case of Korea, well, what is the case of Korea? Korea had been colonized by Japan, had a GNP per person of $100 at that moment, and in a few years it became 10,000, and now is 30,000, 40,000, and so on. However, the case of Korea must be understood. There are two elements in the case of Korea which are important and must be understood. First of all, there was the war in Korea. The war in Korea meant that automatically South Korea received a tremendous support from United States mainly. Well, it was United Nations, but in practice it was United States. But second is that their policy was not only a policy of technological development. The policy of innovation, the policy of copying the first world, which is basically the policy by which Japan, 1 century before, in the Meiji, when there was in the Meiji period, the transition to the European science, well, it was European mainly, to European science, was accompanied by tremendous effort in science. So in practice, to say that the Korean case shows that innovation worked is lying, because one simply put under the rug the fact that there was a parallel action in science which was of tremendous impact. And in fact, also, if you look now, a level of infrastructure, Korea has many infrastructure, even synchrotrons in Korea you find, just as in Japan and so on.